today we're finding the areas of trapezoids and kites and some rhombus. You guys remember the definition of a trapezoid? What makes a trapezoid a trapezoid?
Like one pair of parallel sides.
Okay, one pair of parallel sides. Remember what we call the parallel sides? Bases. So we got like base 1 and base 2. Remember what we call the non-parallel sides? Legs. Okay, trapezoids could look like that, could look like that, could look like a lot of things. This would be a trapezoid, right? But the bases are the vertical sides, not the other sides. Yeah. So, does anybody want to guess how we could find the area of a trapezoid?
Isn't it like base 1 plus base 2 divided by 2 times height? Or is that something else?
No, that was it, yeah. You remember it? Well, here's how I think of it. This is kind of a bigger formula, so might help to understand where it comes from. If I pulled this out and then push this in at the same time until they were straight up and down, what shape would I make? A rectangle, right? If I pulled this out a little bit and I push this in to keep it balanced, it'd be a rectangle. And what was the area of a rectangle? How do we find the area of a rectangle? Base times height, right? So, but this base would not be the same as this base or this base. What would the base equal if I pulled that out and pushed it in? The same amount. Well, the base would be the average of these two bases, right? Because it'd be in the middle of these two. And then the height would be the same as the height of the trapezoid. So instead of base times height, it's average of the bases. That's how you average two numbers, right? Average of the bases times the height. So that's the area for a trapezoid. All right, what is that shape? Kite. And what are these lines that I drew that make a cross? What kind of lines are those?
Perpendicular.
Well, they are perpendicular, but what are the lines called?
Angle? Lines.
Starts with a D. Diagonals. So it turns out, I don't know how they figured this one out. I haven't seen the proof or anything. They didn't tell us. But it turns out that the area of a kite is always diagonal times diagonal divided by 2. Diagonal times diagonal divided by 2. So if this was my kite, what would my diagonals, how long are my diagonals here?
8 and 10.
Yeah, 8 and then 10. So if this was the problem, you do 8 times 10 divided by 2. It's be like 40 units squared. Okay, so it's just diagonal times diagonal divided by 2. Okay, rhombus, we did talked a little bit about it yesterday, but how do you find that area of a rhombus?
Parallelogram.
Parallelogram, so what?
Base times.
Base times height. But sometimes another trick works. On a rhombus, and since a square is a type of rhombus, this would technically also work on a square. It turns out that you can also do diagonal times diagonal divided by 2. So that works on kites and rhombus. Alright, those are the 3. Something else we know on a parallelogram is like these two are the same length, these two are the same length, these are 90-degree angles. Anyways, Alright, got it? Got all three of them? Back to the top. Okay, so on number 1, state the area formula. See how many of these you guys can do from memory. How do we find what's the area formula for a square? Well, base times height would work, but what's more specific for a square? Right. Since all the sides are the same, you just take one side times itself, so side squared. Rectangle. How do you find the area of a rectangle?
No, base
Base times height. Parallelogram. Base times height. What's the difference on a parallelogram though? The height would not be the side of the parallelogram. It'd be the vertical line. D is triangle. How do we do triangles? Base times height divided by 2. E is trapezoid, okay? Might not remember this one from a couple minutes ago. How do you do trapezoid?
Like the average of the bases and then height.
Average of the bases, which is base plus base divided by 2, times the height. And I think the next one was the order we said it. So kite, what was the kite one?
Diagonals.
Diagonal what?
Times diagonal 2.
Diagonal times diagonal divided by 2. A, B, C, D, E, F, E. Okay, then rhombus. What's the rhombus?
Same thing.
Base times height, or they put 2 of them on this one, or the diagonal thing. Diagonal times diagonal divided by 2. All right. So on number 3, what kind of shape is that? Trapezoid. So we need to average the bases times the height. So what are the bases? 12 and 22. So you average 12 and 22 and then multiply that times the height. Okay, don't forget, just like yesterday, let's see, we got meters. So this would be meters squared. All right, trapezoid. Number 5, what shape is number 5? Kite. So the formula was diagonal times diagonal divided by 2. Okay, there is a trick on 5 and 6 and 7. But let's look at number 5 for now. You guys see what the trick is? What makes this one tricky?
Just feet in yards.
Yeah, they on the top part they say like 5 feet, and then on the bottom they say 1 yard. So how can we fix that?
Convert it to
Yeah, probably the easiest way would be to convert each yard into 3 feet, right? These are not square feet or square yards yet.
No hot lunches tomorrow.
Okay.
Everybody got that?
Cooks are still sick. This is for me. put it on the board and just crawl down there by itself. All right. So, what would the vertical diagonal, how long would that be in feet? 8. It's 5 feet plus 1 yard, so that'd be 8 feet. And then what is the horizontal diagonal? How long would that be? 6. 3 feet plus 3 feet. So we need to do diagonal times diagonal divided by 2. And we converted to feet, so it would be square feet. In the other class I was going too fast, and I did not notice that they used different measurements. So we had to go back and fix it. All right, number 7. Do we have to fix any measurements on this one? Yes. Okay, because on the right side it says 6 inches, not 6 feet. So it would make sense if that was 6 feet and the left side was 1.5 feet. So we could, you can choose. We could convert feet into inches or inches into feet. Which one do you guys think would be easier?
No, I didn't.
Incorrect.
Inches.
Inches.
Could it be like,
That's what you get for whispering something.
What?
All right. Well, it doesn't really matter. It's about the same. The only reason I would change inches into feet is because, well, it's just 6 inches. So that wouldn't be too hard to change into feet. And also that's the only inch measurement that they have. What shape is number 7? I never asked that. No. Definitely not a rhombus. It's a trapezoid because...
oh, I was gonna say 6.
Because why? The vertical lines are parallel, right? It's a trapezoid. So the vertical lines are the bases, so it's kind of like sideways from how it normally looks, but it is a trapezoid. So what is 6 inches in feet? How many feet is 6 inches? Huh? 0.5, half a foot, right? So our bases are 1.5 feet and 0.5 feet. So remember we have to average those on a trapezoid. So we have to average the bases and times the height. What would the height of the trapezoid be? 2, because it's lying sideways. There's kind of a quick way to do this without a calculator. You guys, anybody know what it is? There you go. Good job, Lisa. Totally redeemed yourself.
Goodness.
All right. Anyways, the 2's. Yeah, remember multiplying fractions, how you can like cross cancel. And we got 1.5 plus 0.5, which is 2, over 1, which is 2. So anyway, it is 2. It really wouldn't have been that hard to change feet into inches. Normally that probably would be the easier method. I was just kind of teasing, but kind of serious also. Number 9. Actually, maybe we should look at number 8 because that might freak people out. What shape do you guys think number 8 is? Rhombus. Technically, it's not a kite because all 4 sides are the same, and on a kite you're supposed to have different lengths, but it kind of is like a kite, but it's a rhombus. So, how do we do the rhombus? Well, base and height would be pretty hard to figure out, but diagonals would not be too hard to figure out. So the diagonal would be like, how far is it from X to Z, right down the middle? Yeah, it's going from 0, 2, so up to, straight down to 0, negative 2. So that's a 4. So the first diagonal is 4, like XZ. And how long would WY have to be? Right, from -3 to 3, that's the 6. So the diagonals are 4 and 6, so. You guys remember how we labeled this one yesterday? We did one of these. Yeah. Okay. Number 9. What shape is number 9? Trapezoid. So if it's a trapezoid, we need to find the what? What values do we need to find to figure that out?
The bases.
Bases, 2 bases, and the height. Okay, so let's start with the bottom base, AD. How long is AD? 6. From 0, 0 to 6, 0. Just move 6 to the right. So 6 is the first base. What's the BC? How long is that? From 4, 4 to 7, 4. Yeah, it just moves from 4 to 7 on the x-axis. So it's 3. So those are the bases. We are supposed to average those. And then the height. So on the y value of the height, it goes from 0 at the bottom up to 4 at the top, right? So how tall is it? 4. Could we use that trick from number 7?
Yeah.
6 plus 3 is 9 times 2.
Whoa, that was amazing.
A little bit faster than calculator. They grow in big bunches.
My trees.
Mm-hmm.
Oh my goodness.
All right. Number 11. Rhombus. What was the rhombus formula? We're still finding area. For 11.
Like distant, or like the D and the D divided by 2.
Yeah. Diagonal times diagonal divided by 2. By the way, before I forget, on number 6, make sure you convert to the same measurement types because they're different. Okay, on 11, so it's just 27 and 13 are the diagonals. So it's 27 times 13 divided by 2. Alright, what did that come out to? Okay, 13. Yeah, this is where I first noticed they weren't using this. So, a trapezoid base is 20 inches and 7 inches and height of 2 feet. So, what should we do first? What's the trick on this problem? Well, okay, you average the bases times the height, but what's the problem?
Oh, I'm not getting that answer. I got 1.1.
That's 27 times 13, not 27 point.
Yeah, I put 27 times 13.
Alright, girlie.
How'd you do that?
Push the buttons. I don't
Oh,
know.
times I could divide. Cause girl, that's why.
Okay, what, nobody sees a problem. Okay, so if I did average of the bases was 7, right? Times the height, something is wrong with this.
24, not 2.
Okay, the height is 2 feet. These are 20 and 7 inches. So what does 2 feet turn into
24.
in inches? Yeah, each foot is worth 12 inches. So to get them the same measurement type, we can change 2 feet into 24 inches. My little trick doesn't help as much on this one because it's still like 27 times 12. 54 plus 270. What's the inches, right? This chapter isn't that bad, is it? I feel like when we get to the test, though, it's maybe a little harder than people realize. I feel like I get disappointed when we get to the test. 15. You and a friend decide to build kites. Each with the, have you guys ever put a kite together? Each with, never gone and flown kites? They don't, you don't buy them at the store in working condition. They come in a little bag and put it together. Well, they give you the parts and you just like put it together, like IKEA kind of thing. All right. Anyways, you and a friend decide to build kites, each with a 3-foot spine. What is a spine? Yeah, they drew a picture on the right. It's what you might guess, just like your spine. It goes right down the middle. Okay. So, and a 2-foot spreader. What's the spreader? Spreads it out. Yeah, the horizontal bar. Horizontal spar is what they call it. Okay, and then it says, here's where it gets a little bit confusing. The spine extends 6 inches over the spreader in your friend's design. What do you think that means?
The bottom line, or like the longer part of the line.
So, they're saying on the friend's design, the spine is 6 inches over the spreader. Like up here, 6 inches. So what would that leave for down here? I think they said the spine was like 3 feet, right? Yeah, 3-foot spine. So if there's 6 inches up here.
I mean, 30.
Oh, yeah, yeah. Oh, well, I was thinking in feet, I guess. 30 inches, yeah. Okay. Or I was thinking like 2 feet and 6 inches. These are the same thing, by the way. 2 feet, 6 inches, and 30 inches. And then they said the spreader was 2 feet. So it'd be like 1 foot on each side. And then, anyway, okay. And then it says... it extends 12 inches over the spreader in your design. So this was the friend, and on your design, it's 12 inches over. So that would leave like 24 inches down here, and it'd still be like 1 foot, 1 foot. Okay. Does that kind of make sense? Drawings weren't terrible. So his spreader is a little bit higher up on the kite than the one we did. So the question is, which kite, if either, will require a larger sail? So the sail is just like the plastic or whatever that covers it.
Does it cover the whole thing or just the bottom?
The whole thing.
Okay.
So which kite is bigger is what they're asking.
WI. They're both like same size kite.
Yeah, they would have to be the same. Why are they the same? How do we know that they're the same?
Still 3 feet on the spine.
Yeah, the diagonals are the same. It doesn't matter if you move this up or down. It's still going to be the same diagonal times diagonal. So
He's still recording.
It's quiet. No singing.
You realize he's
You
not
play
gonna
an
post it
instrument.
now, right?
You should.
You think people are watching my
He's gonna
videos?
crop it out.
I mean, don't you have like 100 subscribers or something?
He almost does. Or, I don't know. He probably passed.
Yeah.
I think you have to sing like, or play a certain length, like enough of the song before it gets banned
Really
anyway.
get a package from YouTube.
Copyrighted, yeah.
Dude, Mr.
Guys,
Jordan, you
we
could
have
be
to
acapella.
go.
Wait, what are
Jordan's about to get spotted.
It's not
I
set
got
up.
my first to play with.
Yeah.
No,
You
we're
know,
not
it's
gonna
subscribers.
listen.
Are you only
I told the other class,
Yeah.
18, I'll make 18 bonus. So why don't you guys give 18 a try for bonus? Yeah. It's not that bad.
18 looks wacky though. Looks like
Wasting the brag 18. Oh, 18 buttons. Oh, okay. Great.